Okay, so in this video I want to show you maybe the most famous or one of the most well-known formulas in algebra, and it's okay if you haven't seen it before, obviously it would be new, but I want to show you it's called the quadratic formula, and it's a third way for us to solve quadratic equations, or actually a fourth way. We've talked about solving them by graphing, solving them by factoring, solving them by completing the square. This is method number 4. It's always nice to have multiple ways to solve a problem in case one of them is not available or one of them tends to be easier for you. Okay, so this is the formula right here, by the way. The quadratic formula is this. It's x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is divided by 2a. So that's quite a mouthful, especially if you've never seen it before. You might look at it and say, where on earth did that come from? And that's the point of this video. I want to show you where it came from and specifically kind of prove it to you that it's based on something that you already know. Okay, that formula, math is not primarily about memorizing things, but that formula is so important that I would recommend memorizing it. And there's a lot of kind of songs and different jingles that you can find if you just do a search. There's one that's sung to the tune of Pop Goes the Weasel. It's pretty annoying, but that's actually a good thing because the more annoying it is, the more easily it will stick in your mind. So I would recommend memorizing that. But now I want to show you where it comes from. So basically, it comes from completing the square. It comes from the process of completing the square. So you can see we have a split screen here. On the right side is a regular quadratic equation, and we're going to solve that using completing the square. And the left side is a quadratic equation in standard form. ax squared plus bx plus c equals 0. And I'm going to show you a step from each problem, and over time it's going to start to look like the quadratic formula. So let's do that right now. So our first step in completing the square is this number doesn't factor, so we move it over to the other side. So we're going to add 93 to both sides. We would have 6x squared minus 12x equals 293. Same thing over here. This is not going to factor, so we'll move that c over to the other side. So we'll have ax squared plus bx, and that's now equal to negative c. Okay, now on this side, remember that completing the square only works when this number is 0, and right now, or sorry, not 0, but 1. Right now it's not 1, so we need to divide everything by 6 in order to make it 1. So when we do that, we're going to get x squared minus 2x, and then 93 over 6 can reduce to 31 over 2. Same thing over here, we need this number to be 1. It's not, it's a, whatever a might stand for, so we're going to divide everything here by a. So when we do that, we will get x squared plus b over a times x, and that's equal to negative c over a. Okay, now on the right side, going back to the number example, we left a big space there so that we can complete the square. And just to recall, the way that we complete the square is we take half of this number and square it and add it to both sides. So half of negative 2 squared is negative 1 squared, and we're going to add that to both sides. Okay, so now let's simplify this. We have x squared minus 2x plus, that's going to equal 1. And this number here is 1, which is the same as 2 over 2. So 31 over 2 plus 2 over 2 is 33 over 2. Okay, on this side we need to take half of this number. What's half times b over a? And the answer would be b over 2a. So that is half of the middle term. So we're going to square that and add it to both sides. We get b over 2a squared. And now let's simplify that. So we're going to get x squared plus b over a times x, plus if we square the b, we would get b squared, and if we square the 2a, we would get 4a squared. On this side, we're going to have the same thing, but then we need a common denominator in order to add these together. And you don't have to worry so much about this next step because we haven't really talked about it yet, but just to mention it. Or actually, we'll come back to that in just a sec. Let's continue with the other side. I want to fix this first. So this is now a perfect square that can factor. That's the same as x minus 1 squared. The minus 1 came from half of this number, and that's still equal to 33 over 2. Okay, this side, what does this factor to? That factors to whatever half of that number is. And remember, we found that up here. Half of that number was b over 2a. So that's the same thing. Okay, how do we add these together? We're going to have negative c over a. The common denominator here would be 4a squared, so I need to multiply a times 4a, and that will give me, or that will give us our common denominator. So let's rewrite that for a sec. So the top right there is going to become negative 4ac, because negative c times 4a would be negative 4ac. The bottom is 4a squared, and then this side stays the same. And all I'm going to do here is I'm just going to reverse the order of these. So I'm going to put the b squared in front. I'm going to put the minus 4ac to the other side. And there is our 4a squared. So now both sides look very similar. Okay, now let's recall, how are we supposed to solve for x right here? It's being squared, so we need to square root both sides. And in front of that we put a plus or minus. So those cancel. We get x minus 1 equals plus or minus this right here. And our last step would be to add 1, and there's our answer, 1 plus or minus. And of course we could simplify that by not having the radical on the bottom. We'll save that for a future lesson. Same thing right here. Now, one thing I want to point out, earlier in the unit we talked about the vertex of a quadratic being located at the point negative b over 2a. And you might not have understood why that was the case, but now you can. If you look at this parentheses right here, what value would make that parentheses 0? Because the thing that makes the parentheses 0, that's the significant value. That's the value where the vertex occurs. So if you look at it, x or what plus b over 2a would be 0, and the answer is this, negative b over 2a. That's why the vertex occurs at this x value right here, because that's what makes that parentheses 0. So let's square root this. And remember, when we square root something, we'll put a plus or minus in front. And square rooting a fraction is really like square rooting the top and the bottom separately, or at least you can do it that way. So that's what I'm going to do. Okay, these will cancel, and we're just left with x plus b over 2a equals plus or minus b squared minus 4ac. And the bottom we can actually take the square root of. What's the square root of 4? That's equal to 2. And the square root of a squared, squaring and square rooting cancel, so just left with a right there. Okay, we're almost done. The last thing we need to do on the other side there, it's x plus b over 2a. The last thing we want to do is subtract the b over 2a. So that goes away, and negative b over 2a. And now notice we have a common denominator here, so we can simplify this by saying negative b plus or minus the square root of b squared minus 4ac. And that's all over 2a. And sure enough, that right there is the quadratic formula. We just proved that it came from completing the square. So it's basically a finished version of the completing the square, where you just have to plug the numbers in. Okay, you certainly don't have to memorize that. At least in my class, students are never required to memorize that. I doubt your teacher would, but the reason I want to show you is because it's nice. I never liked it when somebody just gave me a long and complicated formula and said, here, just take my word for it. I want you to understand, where does that come from. It's not something that mathematicians just invented one day, or pulled out of thin air. It's something that they discovered arose from a process that they already knew was valid. They knew it came from completing the square. So in the future videos, I'm going to show you now that we know the formula and we know that it's true, that it comes from completing the square, which is a valid algebraic process, I'm going to show you how to actually apply that to specific problems. So stay tuned for that.